Okay, Bismillah. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lesuzri, last NRP 007. And in this video, I will demonstrate my code for the third practical. And let's go into the first question. So the first question, we have the key n and w data structure. And so basically, the uh, sorry. So yeah, basically, so Canon with data structure, um, uh, so we are given undirected, unweighted graph, so we must find all the nodes that are exactly L step away from a string node S using the breadth first search, or we call it BFS. And so our goal is output all nodes at exact level L from node S, and if none, print not found. And the core of this algorithm is for it's like run BFS from node S and then track levels of all nodes and then collect and print nodes at level L. Maybe we can demonstrate it. Maybe I will explain my code first. So basically yeah, for this one is for this random number of nodes and age, target distance, and starting node. And then we move on into this one is for build agency list of the graph. For so each edge connect with node U and node V in both direction. And then this one is for holds the shortest distance from S to I, and then initially all distance are -1, meaning that means the node is haven't visited yet, and then BFS Q start from the node S. And then so this one is for the BFS bird search loop, and then this one is for oh sorry, this one is for BFS, and then this one is for finding node at level L. So it's gonna be checked which node are exactly L step from S, and then prints them each on its own line. And if sets found, it's gonna be true if any are found. And then if any and if none found, it's gonna be if no, it's gonna be not print out, not found. Yeah, maybe we can start. Oh, we can. Oh, okay. Wait, sorry. Okay, we have the correct answer. Not found. Okay. Oh, yeah. Okay, maybe we can move into the next question. So for the next question, uh, we given undirected weighted graphs, and then we need to find the shortest path from a string node S to a destination node E. So the goal is print path found with cost X if the path exists. If not, it's gonna be print out impossible to find a path. And so the core algorithm is gonna be using Dijkstra algorithm, and then track the procedures of the reconstruct of the path. Big and so Yeah, first of all, of course, we have the struct for the we have struct, and then we input reading and consent check for this one, and then build a director graph, and then initialize the Dijkstra algorithm from this one until this one is for initial Dijkstra algorithm. So yeah, the distance sorted distance is from S to node I, and then initialize to infinity. And then parent array is gonna be used to reconstruct the shortest path ladder. And then oh yeah, this one is for this one is for Dijkstra algorithm for loop. So it's gonna be start from the source node S with the distance 0, and for each neighbor phi of node U relax the edge if a shorter path is found. And also it's gonna be keeps track of the best known distance and parent. And it's gonna be just for the output of the result. Yeah. Okay, maybe we can try. Okay, path found would cost path would cost 12 0 1 2. Yeah, it's gonna be impossible to find a path. Okay, we move into the next question. So the third question, basically, is gonna be we gave an undirected weighted graph again, and then undirected before it's directed, right? So so for this question, it's for undirected weighted graph, and we need to determine if any path actually it's not necessarily simple or shortest, just the axis with total weight exactly equal to x. Yeah, equal to x. And then our goal is just for print yes if such a path exists, and then otherwise it's gonna be print no. And for the core of the algorithm is use the FS depth first search with weight accumulation, and for each node try to explore different paths while avoiding immediate revisits. Okay, maybe we can move into the code. Yeah, it's gonna be print out. No, no. Wait. I'm sorry. I think I haven't checked again for the result because to be honest I used ChatGPT for this one because it's kind of complicated, but yeah, I think I haven't checked again for the output. So maybe we can go into the next question. But actually I get the idea for the that question. So yeah. Okay, and then for the last question. So the assets for each test case is given undirected graph content exactly one cycle. For each case, check if given undirected graph content exactly. And so the goal is gonna be print. I'm sorry. I think oh sorry. I think I got the wrong code for this one. Oh yeah, yeah. I'm sorry. Uh, okay. Okay. Uh, I'll explain this one. So yeah, basically the goal of this program is for detect if there is a cycle with three more distinct vertical and print the short list of the vertices involved in the cycle if found. Otherwise, it's gonna report no cycle detected. And then for the first one, we built a key data structure for graph O, for agency visited O, marks if you have visited one stack, tracks if node currently in the DFS, and parent to reconstruct the cycle path. A cycle set is for the stored nodes, and then found cycle is global flag. Okay. Uh, and then we have some Boolean expression for the DFS function detecting a cycle. So U is a current node and P is for the parent node in DFS3. And then so the key step is gonna be for the visited, mark the node as visited and put it on the DFS stack and check the neighbors for this one. And then yeah, it's gonna be into the main function, loop over the each test case, and yeah, for this one it will be gonna be input and parsing and reset, and for the also for this one it's gonna be read the edge, and this one is gonna be it's for run the FS to detect the cycle, and voila, we got the same. Oh yeah, we got the same expanded output. We move into the last question. Actually, it's gonna find this way, but yeah. Sorry for that. And yeah, so for the find it, so the goals for this question is for print yes. Sorry, it's gonna be determine um, if any path exists with the total weight exactly equal to x, it's gonna be print yes. Otherwise, it's gonna be print no. Also, with using the fs though. Okay, maybe we can start. Mm, okay, so I will explain the code first. So first of all, we declare a global declaration. So max fee is for the maximum number, graph for the agency list, and found is for the global flag, and the fs function for this one is the fs function, and then we move into the uh yeah, this two this and this is the key idea for the DFS. And in the main function, we have the input loop to clear previous test case data. And then read each until 000 is encountered, and builds an undirected weighted graph. And then we from this one, it's gonna be the FS launch, and the output is gonna be yes or no. And okay, we have the correct expected output. Okay, I think that's all. Thank you for watching this video, and goodbye.